today's topic of discussion from particle dynamics, and the topic is motion of a heavy particle on a rough inverted cycloid under gravity in a vertical plane. Okay, so we have to discuss the motion of a heavy particle in a inverted cycloid under gravity, okay, where the cycloid is rough. Okay, so we first try to draw a rough sketch of inverted cycloid. What is the meaning of inverted cycloid? Inverted cycloid is nothing but in the vertical plane if the vertex in the downward direction. Okay, like this is the rough sketch of cycloid. Let it be cycloid, right? And this is the vertical axis taken as y-axis. This is y-axis, and this is horizontal through O. This is the vertex of the cycloid, and this is x-axis. Okay, and since vertex is downwards, so this is inverted cycloid. Okay, let at any time p be the position of the particle. This is p, and we draw a tangent to the cycloid, and let the tangent at p makes angle psi with positive direction of x-axis. Okay, and since p be any point, here we let OP, this is the arc, and it is measured from the vertex, which is the fixed point on the cycloid. Let it be S. Okay, and in this case we know that the intrinsic equation of the cycloid is given by S. This is equal to 4A sin psi. Okay, here A is the radius of the generating circle of the cycloid. Okay, here A is the radius of the generating circle of the cycloid. Psi with the angle which already mentioned here, and S with the arc length which is measured from the fixed point, which is the vertex of the cycloid. Okay, now since this is rough, okay, then resistance force must be applied on this particle. Okay, and resistance force applied in the direction opposite to the motion. So the resistance force act through the tangent on the direction of TP. Let it be the point T where the tangent intersect the positive x-axis. Okay, and let mu be the coefficient of friction. Mu be the coefficient of friction. And R be the normal reaction. And we know that normal reaction always act perpendicular to the tangent at the point of contact. So this is the direction of normal reaction. Okay, and we get the normal reaction at the point P, which is R. And clearly the friction force act along PT, and it will be mu R, because mu is the coefficient of friction and R is the normal reaction. And the weight of the particle, because the particle is heavy particle, so weight of the particle, this is mg, which act vertically downwards. This is mg, right? And m be the mass of the particle. M be the mass of the particle. Okay, now here we consider the tangential and normal equation of motion of the particle to discuss the total motion or total cycloidal motion. And we know that the tangential acceleration and normal acceleration are, we first write tangential acceleration. This is m v dvds. This is tangential acceleration, which act in the direction where the arc length is increasing, right? That is in the direction of TT. And normal acceleration acceleration which is given by mv square by rho. Okay, and rho with the radius of curvature at the point P, and v with the velocity at the point P of the particle. Okay, now we resolve all the forces along tangent and normal, and it is clear that if this is psi, so this is clearly 90 minus psi. Okay, and we give here the angle pi by 2 minus psi. So the total tangential acceleration are given by, one of them is mu r, this is positive because this is in the positive direction or increasing direction of s, this is mu r. So we write here the equation of motion mv dv ds, this is tangential equation of motion, this is mu r, and another is the component of mg along in the direction of this is given by mg cos pi by 2 minus psi, because the angle is pi by 2 minus psi. So we get the another force which is mg cos pi by 2 minus psi, this is negative force, because this force try to decrease the value of s. Okay, so we get this is minus, this is mg cos pi by 2 minus psi, sorry, this is minus psi, and we get this is mu r minus mg sin psi, and this is equation number 1, and this is the tangential equation of motion. Now we write the normal equation of motion. We write here mv square by rho, this is equal to, here we get the normal in the inward direction which is taken to be positive. So r in the inward direction normal. Okay, so r is the positive normal force, this is r, and the component of mg along the opposite of r, which is given by, since this is psi, this is 90 minus psi, and obviously this is equal to psi also. Okay, because the tangent and normal makes angle pi by 2, so this is psi. So we get the component of mg along this direction is given by mg cos psi, and this is the negative to the normal direction. So we here get this is minus mg cos psi. Okay, and this is second equation of motion, this is the normal equation of motion. These two are equation of motion, this is normal, and this is given by tangent, tangential, and this is normal. Okay, and from the intrinsic equation of cycloid, we first find ds by d psi, which is given by 4a cos psi. Okay, and ds by d psi, this means rho. This is equal to 4a cos psi. This is the definition of rho in intrinsic coordinate. This is rho, this is 4a cos psi. Okay, now from 2 we first find the value of normal direction r, which is given by m v square by rho plus mg cos psi, and now putting the value of this r, let it be equation number 3. Putting the value of r in the first equation, and we get the result as 1 implied, this is m v dv ds, this is equal to mu into m v square by rho plus mg cos psi minus mg sin psi. Okay, and this is from 1. Now we cancel out m from both sides, and getting the result as v dv ds, this is equal to mu v square by rho plus, this is g into mu cos psi minus sin psi, right? This is mu cos psi minus sin psi. Now this equation can be written as half into dv square by ds. Okay, because half into dv square by ds, this is equal to v dv ds, and this is minus mu v square by rho. This is equal to g into mu cos psi minus sin psi. Okay, now putting or multiplying all the equation and both sides of the equation by rho, we get the result as half into dv square by ds into rho. Here rho, this is, we already say here, ds by d psi. So we get ds by d psi minus mu v square, and we together multiply by 2, then this is 2, and right side is given by 2g into mu cos psi minus sin psi. Okay, and here is also a rho, and now putting the value of rho directly here in the right side only. Here rho is 4a cos psi, so we get this is 4a cos psi. This is given by 8ag into cos psi into mu cos psi minus sin psi, right? And left side is given by dv square by d psi minus 2 mu v square. Okay, and clearly this equation is of the form dv square by d psi plus p into v square. Okay, this is equal to q, and this is the form of linear differential equation of first order, and this is a linear differential equation of first order in v square, right? So we get the integrating factor of this differential equation as integrating factor. We write here integrating factor is equal to e to the power integration p d psi. Okay, here p is minus 2 mu, so we get e to the power minus 2 mu psi, because minus 2 mu is constant. Okay, so by multiplying by the integrating factor this and integrating, we get the result as the left side is d psi of v square into e to the power minus 2 mu psi, and the right side is 8ag. This is e to the power minus 2 mu psi into cos psi into mu cos psi minus sin psi. Now taking integration, we get v square into e to the power minus 2 mu psi, and the right side is 8ag integration e to the power minus 2 mu psi cos psi into mu cos psi minus sin psi d psi plus this is an integrating constant which is taken to be c. Okay, now here we give an important trick to find the integration very easily in short method. Now to integrate this integration very easily by short method, we put an important substitution. This is given by e to the power minus mu psi into mu cos psi minus sin psi. This is equal to z. We put here. Okay. Now by differentiating, we get, if we differentiate this relation, we get the relation as minus mu e to the power minus mu psi. This is the differentiation of e to the power minus mu psi into mu cos psi minus sin psi. This is the first term, and the second term is given by plus e to the power minus mu psi into, this is mu into sin psi, this is minus cos psi into d psi, this is equal to dz. Now taking common e to the power minus mu psi, we get the result as minus mu square cos psi plus mu sin psi, and from here we get minus mu sin psi minus cos psi d psi, this is equal to dz. Okay, so we get e to the power minus mu psi, this cancel out, and taking minus common, this is mu square plus 1 into cos psi d psi, this is equal to dz. So we get e to the power minus mu psi into cos psi d psi, this is equal to dz by 1 plus mu square and 1 minus r. Okay, so from this integration we can write the result as b square into e to the power minus 2 mu psi, this is equal to 8 ag. We write here the right side, this is e to the power minus mu psi into cos psi, e to the power, we write e to the power minus mu psi into cos psi d psi, this is equal to this. So we write first minus dz by 1 plus mu square, and another e to the power minus mu psi into mu cos psi minus sin psi, this is equal to z. Okay, so total integration is given by minus z into dz by 1 plus mu square plus an integrating constant, this is c. Okay, so we get b square e to the power minus 2 mu psi, this is given by 8 ag by 1 plus mu square, this is minus, and z square by 2 plus c. Okay, now we get v square into e to the power minus 2 mu psi, this is equal to minus 4 ag by 1 plus mu square, and the value of z we put here, this is e to the power minus 2 mu psi into mu cos psi minus sin psi whole square plus c. Now v square is given by minus 4 ag by 1 plus mu square, e to the power minus 2 mu psi and e to the power minus 2 mu psi cancel out, and one term remains here, this is mu cos psi minus sin psi whole square plus c into e to the power minus 2 mu psi. Okay, we get the total integration of this line. Okay, now if we take the particle start from rest from a point which is given by A, okay, and at which the tangent at A makes angle psi 0 with the positive x-axis, then if we put this condition, that is the point A as the initial condition, we get initially at A psi, this is equal to psi 0. Okay, we get this because this is a theory type problem. Okay, and we assume psi equal to psi 0 here, and v this is equal to 0 because we let start from rest. Okay, and in this case we put psi equal to psi 0 and v equal to 0, and getting the result as 0, this is equal to minus 4 ag by 1 plus mu square into mu cos psi 0 minus sin psi 0 plus c into e to the power minus 2 mu psi 0. Okay, and getting the integrating constant c, this is given by 4 ag by 1 plus mu square into mu cos psi 0 minus sin psi 0 whole square into e to the power minus 2 mu, e to the power minus 2 mu psi 0. Okay. Now we put the value of this integrating constant in the given result. We get the result as, we write the term, first term, this is given by c into e to the power minus this. So we get the result as 4ag by 1 plus mu square, which can be taken from both the term. Here 4ag by 1 plus mu square, and also here 4ag by 1 plus mu square. So we write this result as, and this is not minus 2 mu psi 0, this is only 2 mu psi 0, because c is given by this into e to the power 2 mu psi 0. So we write the result as e to the power 2 mu psi 0 into e to the power minus 2 mu psi. So we can write this result as e to the power 2 mu into psi 0 minus psi. We can write this result as this. Okay, and into mu cos psi 0 minus sin psi 0 whole square, and the second term is, we write this is minus mu, this is mu cos psi minus sin psi whole square. Okay, this is the complete value of the velocity of the particle at any point p. Okay, and so this is relation number 4, and we write here relation 4 gives the velocity of the particle at any point p, that is psi. Okay, now putting the value of the velocity v from relation number 4 in relation number 3, we get the value of normal reaction. Okay, and get normal reaction from 3 by putting value of v square from 4. Okay, and when we have to discuss the motion of any particle, so in this case, since it is rough, we have to determine two main things. One is velocity at any point, and another is normal reaction of the particle at any point. Okay, this is two crucial points. This is relation number 3 and this is relation number 4. Also, from this equation, that is from the equation of cycloid, we may get the result as ds by dt. This is equal to 4a cos psi into d psi by dt. Okay, and ds by dt, this means v. So we get dt, this is equal to 4a cos psi by v. And if we take the particle, get the time capital T from this point, that is the point psi equal to psi 0, to any point, this is psi equal to psi. So from this relation, by putting the velocity v from the relation number 4 here, we get the required time by integrating as integration 0 to capital T dt, and the right side is 4a cos psi by v d psi, right? This is here also a d psi. So from the left side, this is the total time, from the point A to P required by the particle, and from the right side by putting the value of V we get by integration the time. Okay, so we get the velocity, we get the normal direction, and we get the required time taken by the particle. And this is the complete discussion of motion of heavy particle in a rough inverted cycloid under gravity. Very important topic of constant motion of particle dynamics. Right? Thank you for watching.